One of the questions a lot of people have wanted me to review in the review process is the idea of implicit differentiation. Remember, you can technically use implicit differentiation all the time, but the main reason that you use implicit differentiation is if you have a y variable showing up in your equation, and typically it's a case where it doesn't make very much sense to solve for y, maybe you don't know how to solve for y, or maybe it's going to make things really, really complicated. Remember that implicit differentiation is really just a slight extension of the chain rule, okay? Technically, each variable is its own very simple inside function. And so, if I'm taking the derivative of x squared plus 5x, I don't usually think of the x as being an inside function. We know that the derivative of x is 1, and so multiplying by the derivative of the inside function just isn't necessary. But you can do it all the time, and if there's a y in the equation, it makes a whole lot of sense. So as a reminder, this is the kind of thing that you might see in a free response, maybe a multiple part problem. If you get lucky, they'll tell you what the answer is. This doesn't always happen, but it's a little bit more likely on the free response, especially if they're going to ask you to use it for something else. So let's say they give you a problem like, show that if 4y squared plus 10x is equal to 8 plus 6y, the dy dx is equal to 5 over 3 minus 4y, okay? The challenge to this is you've got to get it into that form. But again, the nice thing is there's a little bit of a checking factor built into it as well. So remember, here's the process. You're always going to multiply by the derivative of the inside function down to the variable level. Okay, we want dy dx, so we're going to be taking the derivative of each variable with respect to x. Okay, so you start out, the derivative of 4y squared is just going to be 8y, but you technically have an inside function of y. So you multiply by the derivative of that inside function with respect to x. Derivative of y with respect to x, we write as dy dx, okay? And then you just continue like normal. So next, 10x, that's 10x to the first, 1 times 10, drop the power by 1, you're going to be left with just 10. Technically, you need to multiply by the derivative of the inside function with respect to x. You're taking the derivative of x with respect to x, and that's dx dx. And by the way, dx dx is equal to 1, and that's why we actually say the derivative of x is 1, okay? Because it's dx dx. We just don't usually show that when we just have x's in an equation. Other side, be careful. This is a constant. The derivative is 0. The derivative of 6y is 6. But we have to multiply by the derivative of the inside function with respect to x, so you get a dy dx. Okay? In the end, dx dx is just equal to 1. I would leave it as part of your work, but obviously it's not really affecting anything here. Okay? Remember, your final key is to solve for dy dx. And this problem, we have a little bit more of a challenge because we have a dy dx on both sides of the equation. Okay? You want to get all of the dy dx's on one side of the equation, everything else on the other side of the equation, okay? It doesn't matter, but keep in mind that your signs could all be the reverse of what the signs are in the problem. Just for the heck of it here, I'm going to move the 10 over here, and I'm going to move the dy dx over here. So we'll get 8y dy dx. I'm going to subtract 6 dy dx from both sides. Okay, and I'm going to subtract 10 from both sides. We get the whole thing equaling negative 10, all right? Once you've got all your dy dx's together, you should be able to factor out dy dx from both of these terms, okay? So I'm going to factor out the dy dx, okay? And it's going to come out front, or it can go behind it, doesn't really matter, okay? Dy dx is being multiplied by all of this, so I want to divide both sides by 8y minus 6, okay? And what we're going to be left with is just dy dx equals negative 10 over 8y minus 6. Now, you go back and look at the original problem, and they said to show that it's equal to this. You'll notice sometimes there's going to be some simplifying that's going to happen, okay? Now, if they don't tell you what the answer is, you can leave it like that, and that's fine, because remember, on AP exam free responses, you don't have to simplify. In fact, you run a risk of making a mistake. But obviously, if they say that's the answer, you got to match that up. So what do we have here? We really have that dy dx is equal to negative 10 over 8y minus 6, okay? And again, it's just algebra 1 from this point. I would notice that everything is divisible by 2, so you can divide all terms by 2, and that would be negative 5 over 4y minus 3, and you start to see things lining up here. Remember I said that the side of the equation you put everything on matters, okay? So you could see all of your sides flipped and you still have a right answer, but it's just written the opposite way. I could multiply the top by -1 and the bottom by -1, right? If I multiply by -1 over -1, I'm just multiplying the whole thing by 1, is what that simplifies down to. It doesn't change anything. So we can always flip the sign on everything in the top and the bottom. And if I multiply the top by -1, that becomes +5. If I multiply the bottom by -1, it's going to be a -4y plus 3, okay? And now you can see here that's the same thing as 3 minus 4y, and you have your final answer. That's all there is to it.